I'm Mike Shapiro from Sun Microsystems, and welcome to FishWorks, where at our secret location inside Sun Microsystems, we've been holed up for the past couple of years working on some revolutionary new storage products. For the rest of the episodes in this series, we're going to take you inside all the features of the hardware and software of these new products with all the members of the FishWorks team. Hey, I'm Mike Shapiro, once again taking you inside FishWorks, and right now I'm here with my partner in crime of many years, Brian Cantrell. And Brian, on behalf of storage administrators worldwide, let me ask an important question. What in the heck is my box doing?
Yeah, that's a question we've had for a long time, and indeed, before you and Adam and I implemented dtrace, I think that was a question that people had about their general purpose systems as well. What is my machine doing? And of course, you and Adam and I implemented dtrace to answer that exact question. And one of the reasons that we set out to do FishWorks is to be able to take some of that technology, like dtrace, to people like storage administrators that have historically not had any more insight than the rest of us about what their box is doing.
Now, if people have been hiding in the cave for the past couple of years, just very quickly, how would you summarize? What is dtrace? What does it do for them?
The dtrace allows you to dynamically instrument a production system. It allows you to figure out safely what your production system is doing, so you can figure out how time is being spent. And I think what we discovered, I think what was a surprise to all three of us, is that in a computing infrastructure, the biggest performance problems were not at the lowest layers of the stack. It was not in kind of the CPUs and the compilers and the operating systems where we're accustomed to dealing with it, but it was way up in the stack. It was way up in kind of the application level of the stack. So dtrace allows you to drive all the way from those symptoms at the bottom all the way to the actual problem at the top.
So I can ask my questions in terms of things that I understand as an administrator about what the protocols are doing. I don't have to understand how we haven't implemented those things.
That's exactly right. Now, what we've done with FishWorks and the appliance here is we've taken that to the next level. We've added a visualization interface on top of dtrace, such that you get to use the power of dtrace without having to know anything about dtrace under the hood. You've got no idea that you're using dtrace. All you know is you're able to answer questions that you couldn't otherwise answer.
Well, let's check it out.
Yeah, so I mean, here we got a box, and we may have a very typical situation. You and I are the storage admins. Phone rings, and the devs are angry because they're saying their compiles are taking forever, and they're blaming the storage. You know, what else is new? And historically, we haven't really had much of a defense to that. I mean, the storage is really the nexus in any business, and the storage we found gets blamed a lot.
Yep.
But now looking at the dashboard, I get a little bit of a start, and I can see that I'm doing a bunch of NFS ops, 38,000 NFS ops, which is a lot. But I can also see that I got a ton of CPU headroom here. I'm not actually consuming that much CPU. So I'm a little bit suspicious. I think that the box may be working actually pretty well. It's just it's being asked to do quite a bit. But what I want to do is click on this over here, and we see I go over to another screen, the analytics screen, and this is showing me the activity over the past hour here. And I've got these various controls to control my view, so I can zoom in, for example, and I can zoom into I can click on this clock with the second hand here to get to the last minute. And here I can see the last minute of data and the last hour of data, so on. I want to look at this last minute of data here. On the one hand, this is valuable. We've got a graph, it's nice and interactive, but we're not getting any of that power of dtrace that we talked about earlier. But in particular, I want to know more than just how many ops am I doing. I mean, like I'm doing 25,000 ops per second. Is that good? Is that bad?
Where is it coming from?
Where's it coming from? Who's doing it? I don't know. I mean, it's ridiculous when you think about it. Like you think a NAS box serves up files, right? Who I'm serving files to and what am I serving seems to be the most basic questions you can possibly ask.
We're pretty much currently sitting at the perimeter of what people are used to.
Which is just nuts. I really think that, I mean, if my 4-year-old son, if he understood we were serving up files, the first question he'd be asking is why? Because he asks why about everything. So he'd be asking, why are we doing this? Why are we serving up 25,000 ops? And prior to this, we wouldn't know why. But with analytics, what we can do is click on this little power drill icon here, and we can drill down. We can drill down by type of operation, by client, by file name, by share, by project, by latency. We've got all these ways of looking at the data. So in particular, I may be interested by, well, just show me by client what's going on here. And you see I get a new view here, and I get all of my clients. So I can see I've got DACE 8 data 0 over here, and DACE 3 data 0 here, and DACE 5 data 0. I can actually, if I can shift click on these guys, if I want to view them all.
You're actually exploring what the system is doing in production in real time right now. We're actually watching the live workload. This is not a replay.
Not a replay.
And you can interactively just click on the data and start asking questions.
And start asking questions. I can take one of these guys, DACE 8 data 0, and I can ask a new question. I can click on this drill icon again and say, hey, for DACE 8 data 0, what are you doing? Show me your file names. And now what I'm going to see is I get a new graph that I've never seen before, and this gray here denotes the fact that we've never asked this question before. With these other questions, we were saving the answers here. Never asked this question before. What's happened behind the scenes is we've kicked dtrace in, and dtrace is allowing us to ask this question for the first time, and we can see the actual file names. If I expand this little file name dialog here, I can see export DACE 8 WS is the top file, followed by export compilers, teamware, prod, lib, locale, C, LC messages, whatever the hell that is. That seems to be our number 2 file. If I actually wanted to view this is a little hard on the eyes. If I wanted to, I could actually view this hierarchically. So I can see the file system. Here I can see coming from export DACE 8 versus export compilers. I can maybe expand this guy, and I can see exactly where these things are coming from.
So I can literally explore what my applications are doing, but now from the server side, I can actually see what my whole enterprise, potentially across a lot of clients, is doing.
From my server side, and in fact, I got those devs on the phone, and they're angry about the speed of their compiles, and actually from the NAS box, I'm going to help them debug their build environment effectively. In particular, one question I've got for them is, hey, this locale C LC messages, what's going on there? Now maybe we're doing a lot of ops to this thing, and maybe we're doing a lot of, who knows, maybe we're doing a lot of writes to this thing. We don't actually know. So let's actually take this file, and let's just drill down by type of operation on that file for that client. So now what we're seeing, again, is something new, never seen it before, NFSv4 ops for the client DACE 8 data 0 for that file, and we can see that we're doing the number of ops per second here, the put FHs and end verifies. These are NFSv4 ops. And now one of the really powerful things I can do here is I can actually drill down by latency. So I can take just that file, just that client, and I can actually see the latency view for those operations.
Right, so I've actually gone now from a macroscopic performance view we started with, which is how many ops, and now I'm all the way down to what is the individual performance of ops for this file, for this client, even for this type of operation, like a read or a write.
That's exactly right. And what I'm including here, so this is a different kind of diagram. I got the time here on the x-axis. I've got time again on the y-axis. This is a bit of a scatter plot. Each data point indicates one op at that latency. The darker the data point, the more ops that latency. Now, what I conclude from this is if I've got the dev on the phone who's complaining about the performance of this compile server, DACE 8 data 0, I'm telling them, hey, look, I'm seeing this thing serving up ops at less than a millisecond per op. So we know that now the storage is not the problem. You've got another problem somewhere in your environment. In particular, maybe we want to go back and ask the question, why are you accessing this file over and over and over again? And indeed, what we would discover is this particular file is something that's involved in the compile. This thing should probably be a local file. This thing probably shouldn't be on the NAS box. No particular reason for this to be on the NAS box. So what we want to do is actually push this to the compile server, and all of a sudden, instead of having to print out a new purchase order to buy new NAS gear or what have you, I've actually debugged the problem in my environment. I've used the NAS box as a nexus in the environment to debug those problems elsewhere.
Right, so it's actually not just a performance thermometer, but it's really, it's almost like everything from a thermometer to the electron microscope, but then also you're now into things like, how do I do my deployment, or how do I do capacity planning? This is actually a tool for all of those things.
That's exactly right. I mean, certainly before, if I had a box that was not performing adequately, before I bought any new gear, I'd want to understand exactly why. And am I not performing adequately because I actually am I/O bound, or am I network bound? What kind of file access am I seeing? Is that the optimal kind of access that I'm seeing? Is there any way I can change my application mix? And this allows you to make architectural decisions too. Like maybe your caching tier isn't working the way you thought it should work. I mean, you and I have both been on customer calls where you show them dtrace output and they say, your tool's broken, that can't happen. It's like, yeah, well, our tool didn't invent the name of some file name in your infrastructure, right? And it turns out they dig a little bit. It's like, oh, wait a minute, your tool isn't broken. Like, we've got a misconfiguration here or something of that nature. So you can find, and those are the big wins in your performance, in your information ecosystem. That's where you can find those big performance wins.
That's right. And you know, while you were talking about that, you mentioned networking, and so we were looking at NFS here. What other things can I see with analytics? What are some of my choices?
Yeah. So I mean, if I just click on this Add Statistic button, I can see all of these choices here. Now, I've actually, this particular user has indicated they want advanced analytics.
Right.
So we're seeing the whole kitchen sink here. For most users, you would see a slightly slimmed down list, but you can see I can see things related to the network. I can see things related to the way the adaptive replacement cache is working. The
so every aspect of the box. We got hardware here. We got protocols, memory, CPU. Everything is covered by this.
Pretty much. I mean, I think that it's certainly everything that is covered in terms of the semantics that the box exports. So for pretty much an arbitrary performance problem, you're going to be able to use analytics to bound the problem and understand where it's actually coming from.
Excellent. And you know, since you mentioned another keyword is export, what if I want to take my analytics data and do something else with it? Can I do that?
Yeah, absolutely. So this little export button here, we got a whole, you know, this giant button bar over here that we do all sorts of interesting things. This little one with the arrow is pretty juicy. That actually gives you a comma separated value for the particular data that you're looking at. So if you want to actually, you know, you finally have it up and you want to actually export it to a spreadsheet, so you can print it out maybe print out onto stone and bash the dev's head with it. You can do it
or I could go in a spreadsheet, whatever I want to do.
Yeah, exactly.
And the other thing is, you know, I noticed we've got all these questions here. We also have a concept of worksheets, so I can actually save a list of questions that are interesting to me. When might I want to do that?
Well, so if you're following a particular pattern of investigation, you've seen something that's interesting to you. You know, maybe this LC messages issue. I think this is interesting. I could actually pause this. If I wanted to, maybe I want to zoom in a little bit. I could sync all these guys up so I get everything on the same time bound, and then I could hop up here and say, you know, investigating LC messages, let's say, and I can save that as a worksheet. Now that is saved, and I can come back at a later time, call that up, understand what exactly was going on. Maybe I want to go to someone else's office and pull this up for them, and so they can see what's going on.
Right. So it's almost like it almost becomes a method of interacting for different administrators in the group, because this is actually a way of sharing information with other people as well as you're asking questions.
Well, and I'll show you how we use this internally.
So we're going to another system to check out some saved analytics.
Yeah, and a system in particular that we've been using for a lot of perf runs internally here at FishWorks. So if we go to the analytics and we go to the saved worksheets, you see a whole bevy of saved worksheets. So what we do is we'll, for example, we will save a worksheet when we're changing things in the configuration. So we can actually look at our performance before and after. Customer may want to do this to understand, you know, I'm going to add some more networking interfaces. I'm going to upgrade it to 10 gigabit Ethernet. So that you want to save these worksheets to represent, you know, whatever you're.
So I can have a whole history of hundreds of different interesting things, maybe even thousands, all built into the system.
All built into the system, exactly, and all easily clickable you can save these things easily, all visual. And of course, we've got, if you want to get to this in a way where you're actually extracting the data automatically, you can get to it via the command line as well. You don't get the graphs, obviously, but you can extract the data via the command line.
That's incredible. And you know, one last question about this is, what software license do I need to access this feature?
Oh, the software license. Yeah, that's going to kind of cost you nothing. Absolutely nothing. Yeah, of course, all the software is on the house.
So analytics built in by default.
Built in by default.
Absolutely free. Safe for use in production.
Absolutely.
All right. This is really incredible. Thanks for showing that to us, Brian. It's terrific stuff. And thanks for being here. And see you next time.